2017 question 10 part A. A particle starts from rest and moves in a straight line with an acceleration of 25 minus 10 meters per second, where v is the speed of the particle. After time t, find v in terms of t. So the acceleration is 25 minus 10v, and we can use dv dt for the acceleration. So dv dt just equals 25 minus 10v. Now we can bring this dt across and multiply, and the 25 minus 10v, we can bring that across and divide. And next of all then we can integrate both sides. And we can use the limits that when t is 0, the initial velocity is 0, and what we're looking to find out what is the velocity v after some time t. Now on the left hand side, here we've got a linear function on the bottom, and if you integrate dx over a plus bx, this is just 1 over b times the ln of the absolute value of a plus bx. So here the a value is going to be 25 and the b value is going to be a minus 10. So we're going to get 1 over minus 10 times the ln of 25 minus 10v on the left. And then on the right hand side, if you integrate dt, this just gives t. And the limits we've got from 0 up to v on the left and 0 up to t on the right. So if we put in v for v first of all, and then minus, and then we have to put in 0 for v. So this gives the ln of 25 minus 10v minus, and when you put in 0 for v, this term goes, and we're just left with the ln of 25. Now this minus 10, we can bring this across and multiply, so we're going to get minus 10t on the right. And we've got the log of a minus the log of b, and this is just the ln of a over b. So we've got the ln of 25 minus 10v over 25 just equals minus 10t. To get rid of the natural log, we're going to get the exponential of both sides, and 25 minus 10v over 25 then just equals e to the minus 10t. Next of all, we'll bring the 25 across and multiply, and you get 25 minus 10v is just 25 e to the minus 10t. If you bring the 25 over, it'll become a minus 25, but if we change the signs everywhere, you get 10v equals 25 minus 25 e to the minus 10t. Now if you factorize out to 25, you're left with 1 minus e to the minus 10t. But then we could divide the 25 by the 10, and v just equals 2.5 and 1 minus e to the minus 10t. In part 2 then, we want to find the time taken to acquire a speed of 2.25 meters per second, and find also the distance travelled in this time. Now we could use this equation to try and find the time, but it would be easier if we use this one that we had previously, that the ln of 25 minus 10v over 25 just equals minus 10t. If we put in 2.25 for v, and then using your calculator, if you work at the right hand side and then divide the answer by a minus 10, this gives a t value of 0.23 seconds. Next of all, we want to also find the distance travelled. So velocity is the SDT, so we can replace this with the SDT, and the SDT then is just 2.5 and 1 minus e to the minus 10t. We can bring the dt across and multiply, and then we can integrate both sides. So when time is 0, the distance is 0, and we're looking to find the distance travelled in a time of 0.23 seconds. Now if you integrate 1, you get t. If you integrate minus e to the minus 10t, this gives minus e to the minus 10t all over a minus 10. And the two minuses would cancel to give a plus. Then we have to put in the upper limit first of all. So we're going to put in 0.23 for t in both places. And then separately we put in 0 for t. So putting in 0.23 first of all for t. And then next of all we put in 0 for t. And using your calculator, the distance s works out as 0.35 meters.